Hello, and how are you doing? Today we are looking, or I want us to look at logarithms or logs. Logs. And we are going to look at logs as a way of undoing something, a way of doing an operation. Undoing an operation. Sorry, my pen is not writing well. As a way or ways of undoing an operation. What do we mean by undoing an operation? If you remember at elementary schools, you were given questions like 2 plus something is equal to 8. This here is the same as 8 minus 2 is equal to box, right? So we talk of subtraction as a way of undoing addition, or addition as a way of undoing subtraction. You can also say it's a way of reversing. Sorry, let me make it reversing. Or the inverse. We say addition is the inverse of subtraction, or subtraction is the inverse of addition. That same way we can talk of multiplication or times as a way of undoing division. Look at something like 45 divided by probably 5, and we say it's equal to something like this, which is the same as what? 5 times what number will give us 45, right? Okay. And just say, oh, okay, so we are just reversing. We just keep on reversing. Let's have this example here. Let's take something like the square root of let me use square root of 4. When we take square root of 4, what does this mean? Take note, square roots mean square, as the name goes. Let me write it here. Square, it goes like square root of 4. So the name here is square. So what this means is this, that there is a number. Let me call that number question mark. We don't know that number. But when we square that number, we are going to get whatever is in the square root. So we are going to get 4. So to undo a square root, we look for numbers that need to be raised to the power 2, or that needs to be squared to get that number. That same way, when we give, are we going to give an answer to this? Okay, question mark will be equal to what? Will be equal to 2. Or you can say 2 squared is the same as 4, so the question mark should be 2. That same way, when you are given the square root of, for example, 49, then we are saying there is a number which we do not know, so we will say it's a question mark. When we square it, we are going to get 49. Sorry, I was supposed to write the 49 in blue. Okay, there is a number which when we square it, we should get 49, like this. And then we go ahead and say that the question mark will be equal to probably 7, because 7 squared is 49. So we use the same idea when we want to talk about logarithms. We use the same idea when we want to talk about logarithms. If we remember, you did some exponential equations. I'm going to write an exponential equation here, like 5 raised to the power a certain number. Let me just use a variable x is equal to 25, which is almost the same as the example that we just did. So to solve this, you will write this 25 as 5 to the power 2. Then you say x is equal to 2. Or somebody will say that 5 to the power of 2 is equal to 25. Therefore, x is equal to 2. I believe that's clear. So, if that is very clear, then to write this here in log form or logarithmic form, then we go like this. We will write the log, which is written as this. Then this 25 will be here. When you look over here, I know you know these, but I'm going to give the names here. This 5 here is called the base, right? What of this 2 here? What's the name given to the 2? Exponent, or it's called exponent, or some people call it the index, or some people call it the power. Okay, so and then this here will be the answer or the number. So when you are to write logarithms, then after writing the log, we bring the base down here. So here the base is going to be 5, and then the result here, which is 25, is going to come next to the log, and then the exponent is going to be here as 2. So log 25 to the base 5 is equal to 2. And over here we call this 5 the base, and this 2 here, as you know, is the answer right now, and that 2 was the exponent, right? If you look at what we brought down here, the 2 was the exponent or the power or the index. Index. And then this 25 here, when we are dealing with logs, that's called the argument. A-R-G-U-M-E-N-T. That's the argument. So we are going to define the log of a number to a given base. Let me write it here. The logarithm of a number. Which number are we talking about? We are talking of the argument. The logarithm of an argument or of a number to a given base. To a given base is, we are talking of the answer. So I'm going to write the answer in red. Is the power, because the answer is always the power or the exponent or the index. Is the power or the exponent or the index to which the base needs to be raised to or must be raised to. Must be raised to give or to result in the argument, to give the argument or the number. Nti me be kan twi mu ase ne e pa kire. Yes, yes, you can say find the log or the logarithm of a number. The APC exchange na I say, term yomo the base be a log nase. Bisa say base no raised to the power number same. And a bema sa number na say find the no log no. Into for example, if I have an example back, infant say the amount in next page. I don't say so I am. Infant say amount log 49 to the base 7. Log 49 to the base 7. In the air here Kenyan I say 7 raised to the power number ben and I'll be near 49. And then be a hand was saying the fact which is a higher exponent. But question when I be any exponent ne where the x and a besho. And I'm saying exponent no the x the besho. Sorry, that's an x. Into the air Kenyan I say base nini 7. To base near 7. And you can say x way exponent into x about 7 is true. Is equal to 49. Into log definition of the air can you any. The air can log definition when you. So we have to look for x. And now himself 49 and so yes 7 raised to the power 2. And to say never got away. Into the air can you and say then since the bases are the same, the exponents also need to be the same. So x is equal to 2. But you say oh yes sure. Tianya back we won't come. Okay, and see amount log 27 to the base 3 to the base 3. And to win so oh yeah awareness saying and say we the equal to y. How to say y and I don't want to y anything back could be then power and an exponent and a 3 way then it's a 3 near base and log to the base 3 of 27. Into your base no winning from indices said there be a base no raised to the power the index and they say equal to 27. Adding Anna. No, what we are equated to say exponential equations are now we in the 3 to the power y is equal to 27. It is 27 here 3 to the power 3. So y here is equal to 3 since the bases are the same. About your want to be as okay. I'm trying to say maybe more another question. The log of y the log of 1 to the base 7. I very good to say. Okay, if I said way equal to Yenim Fabia, we are 101 the sound log 1 base 7. You can see Yenim variable to say z and share. And Yenim say z's way no a power. There be idea and shall log only a power. And I shall log nas near the base. To know say base one, it never shall say no. In Yenim said the base which is 7 raised to the power z is equal to 1. 7 to the power number ben even 1. But to him say 1 wins here 7 to the power 0 and back to the power 0 is 1 provided that number is not 0. In the like I said z is equal to 0. In the fatu trim, we are one of the properties of log. So we see a log. Fatu trim say log of 1 any base equal to 0. Log of 1 to any base. The base near 5. The base near 79. The base near 9. The base near 1 million. We not answer it to be 1. Okay. In the log 3, log 1 to the base 3. Answer is saying. Answer is saying. Into the air Kenya say 3 to the power same. 3 to the power number being any of 1. But which is a higher power and that way your base into 3 exponent. The power question mark is equal to 1. Knowing a question mark need to be saying we need to be saying 0. Yes sir. Now it's a 9 is 0. Okay. Now it's a log 1 to the base 3 is equal to 0. Into the log of any number for 2 to the base, the log of 1 to the base any number 0. Now some for 2 to say see a log at the base can never be 0. Base not to mean 0. That same way my base na some 1 into for 2 to say. Okay. The rabbit back we were. You're gonna say okay, so you can say 1 divided by 25. So we are indices. You can say this is the same as 1 over 5 all squared, and you can say the same as 5 to the power negative 2, and yes, refi go and revisit your indices. 1 out of 25 is the same as 5 to the power negative 2, or is the same as 1 divided by 5 squared, and 1/5 all squared. In this exercise, any amount, the log to the base 5, the base na eshe hono. Na se hano we had 1 out of 25 eshe wa answer na be saying. Inti de bia no we fan say unim answer until the variable be be show yen fan say high x. Na waka ya hu say be a x no de bia wo de say no e ho ye exponent. Pa cho te ase. E bia x na say no e ho ye exponent. And I see how no one de say ho no a base. Inti the year can you na ye say there be a base no which is 5 to the power exponent should give you the argument is equal to 1 over 25. Now I simplify we into bit I can say we have 5 to the power x is equal to 5 to the power negative 2. When your x to be equal to negative 2 into a can log to the base 5 or log 1 out of 25 to the base 5 is equal to negative 2. That's what I say. And say then. Okay. If ever could be my count. Yeah, I can on the fancy amount log of 1 out of 81 all to the base 3. If anything, may count. As a time be out when only for variable be shaha, and answer for exponent eshaha, and for index nashaha. The advance way index no then x. Now what they are showing to himself, we are x no one near exponent. When can say actual exponent shall more through how x way exponent is only there to help you. And a 3 way then base. Yes, sir. Into the air can you answer 3, which is the base, to the power x, which is the exponent, should give you the argument, which is 1 over 81. So we are going to write this and it said 3 to the power x no ha. And I had we say we 1 out of 3 to the power 81 is 3 to the power 4. Okay, 3 to the power 4. So we can say that 3 to the power x is the same as 3 to the power negative 4. So x is equal to negative 4. The partial, the only thing I say no mami. The only thing I say we introduction no. If we are you pay your work na nkasa. You pay work na nkasa. Yeah, no. Me say a friend we no exponent. The shaha we x we no ye exponent. 3 na say log na say hakete no ye friend no base. And a number we na say ha no no. The say bracket mo ha make as say friend say argument. Okay. Into CHRO log 125 to the base 5. Maybe so I say 5 no. Your friend is saying 5 is called Nedin Yeden. Answer is saying base. Yes, sir. 5 in the whole base. And a 125 no. Yeden. The reference was saying refi argument. At the same conform you know any argument no. Your friend no argument. And an answer na ebenya no. The answer ni e kan wo ho no ni na yes yes number ben and a 5 to the power ebe me 125. In other words no 5 exponent what number? 5 exponent what is 125 in simple bro for sada metro. I'm the question mark is here. Question mark with the 5 exponent what is 125? Will be any 5 exponent 3 and I 3. Me quite mean said anymore. 5 exponent sign a 125 3 on. Okay. So it's how the answer 3. 5 exponent 3 and a 125. Me patch log no. The OC who assassin in Sounds near amount, even say amount log of 8 to the base 2. You better 2 ne saying 2 is called nama okay 2 is called what the now the answer show now 8 is called the oh then I'm sure the thing okay into a 2 no the base you have 8 in the same the argument and the using a of what I say you have 8 no the argument okay in the mouth of the last one near to us okay so say if the mouth for the everyone said the log I'm using blue pen the log oh this is use a blue pen the log of 32 to the base 2 and see hand mo say no see it was what question in the paper say the base is what the base is now the answer na sha and then the argument is and also the answer na sha. So which of these two numbers is the base? Is it 32 or is 2? Okay, so the base is going to be 2 and the 32 here will be the argument. It's the air pan. Oh, I had money answer we bear saying yeah per exponent and yes sir. So the base exponent what and a be 32. 2 raised to the power what number will give us 32. That's all we are looking for. And we will be making sure that the answer is 5. Okay. Because here the rules kakra bi eba hanom say. The rules kakra bi eba hanom. Medical can rules maybe I share, but my man yana clear ewa ha. See be yana clear the idea can you na say. See my base log bi na say near no. Log of an argument, the argument is a bracket. No. Number now you're taking a log on your friend argument. Log of an argument as a yina and your friend. Log of an argument to a given base. Number be in the shall say your friend of base. It's always going to give you a number which we call the exponent. And here the friend of exponent, for which the base needs to be raised to give the argument. Fatu Trimo say medical I said the base can never be 0. Okay, so I can was so honorable. Cannot be 0. And I did back be my toss also Shannon so say the base also needs to be greater than 1. The base must be greater than 1. The real maturity in here. And I feel I did back my toss be also Shannon so the argument. The argument also needs to be greater than 1. Must be greater than 1. As I had more bro for now, if a base near no. To my main copy pack and on him feel. Let me take a small eraser. I'm in trouble for Papa. Okay. Into the air cannon, the base must be greater than 1. The air cannon. Young instances are base no. A 0. The air canyon say log a draw numbers be a go. Log for example 5 to the base a. And a is 0. I'm in draw 0. A equal to saying. Into the air canyon say answer a be a 3. And okay, and for x and shall. So the be a sign here. Into the air canyon say base no to the power exponent no. 0 to the power x. A equal to 5. X by a sign. So the base can never be 0. The base can never be 0. That same way the base must be greater than 1. It cannot be 1. Didn't you also say greater than 1? No. You're going to space. I'm not sure why the base cannot be 1. Why? You can ask why the base cannot be 0. But you will know here more examples. You be more examples. Now why the argument also needs to be greater than 0. Why can't the base be 1? Why can't the base be 1? I only ever can want some to say because medical can say the base needs to be greater than 0, and they say it cannot be 0, and they say it can also not be 1. So why can't it be 1? The intent mean you 1 no acquire 1 cardio 1 to the power 4 is saying a1 nebua 1 to the power 10. I'm going to say 1 to the power 10 and say 1 in the amount say log near a base no 1 near the number be shahano mo say they say be 74 yes to find the answer head the back we see then we say high x the base to the power the exponent is equal to 74. 1 to the power sign now being 74. It's not possible. Name of the throne says so this one here is not possible. Name of the throne says log 1 to the base 1 there and keep it me any answer. Anna answer high x you will think I say 1 to the power x, that's the base to the power exponent is equal to 1. Here I can say x is equal to 1. What I say? Alright. And see, when your baby say this one here is ambiguous, into me and yet ambiguous. And I say ambiguity. It doesn't make sense, or it has more than one meaning. So we just don't want it to happen. Until you all say no. You see the argument must always be greater than 0 and also ever honorable. Because so we raise it number bear to any power you get a positive number and okay into the argument needs to be and I want to say maybe I have an example then funny say and on this page nasa let me add another chapter boom okay in this abedu page we are abedu page I'm going to look at why must the argument be greater than 1? Why must the argument be greater than 0? You know, say argument now is 0, I say it basic, but you can find 1 is 0. You know, say 5 raised to the power 2, I say 25. And you say a log 4, why? Because a log to the base 5 of 25 is equal to 2. And yes, and then for log, not log, for 5 to the power a certain number, and be a 0. You will not say, you will not 1. The answers for you 5 to the power 2, 25, 5 to the power 1, 5 to the power 0, 1. You 5 to the power negative 2. You will not say, you will not 1 over 25. In the m1 power no the other point is a power near a real number and one say a positive, say a 0, say a negative, once and also be a positive. In this answer near positive to say the hyena 25, a hyena 1, a hyena 1 over 25 no there. Then the argument, no matter what, argument need to make a negative. Sani a in my main instance argument no be negative. In fact the amount the log of near a whole negative a 8 base 2. That's so we are. In fact say yes so we in fact x and you say x near exponent into the base raised to the power the exponent is equal to the argument which is negative 8. 2 to the power x equal to negative 8. Bisa who say 2 to the power number ben now will be negative 8. So this also becomes ambiguous. We don't want that to happen. We don't want that to happen. Internet, so the argument must always be greater than 0. about your and I say, oh, okay. Since I say, oh, one would the idea, do see, no, a log to the base 10. Log to the base 10. It be more a friend or common log. It be more a friend or common log. Log near what who do me, no, and I, honor. You the friend a common log, no. I know ye log to the base 10. If you log 9 10 as a base, ne honor. And you the natural log. And which way, ever so. But me just sure say most levels no natural log can but natural log. With me they are solving maths. It works just like the common log. In the common log now, the for example which is a log 100 to the base 10. At said the union na if 10 winners shall say I say base 100 way the argument into answer na ye penal ye per exponent. Said the there union no. Answer na ye penal is always the exponent. Into there can say 10 to the power sign and a bema 100. That's all this is about. Into ubia na me be 10 to the power x is equal to 100 a 10 to the power 2. So since the bases are the same, we equate the exponent. X is equal to 2. Therefore, log of 100 to the base 10 is equal to 2. I never have to say, oh, yeah, common log, upper base no one draw. In this whole exams near my question, if you not log no base be answer and say 10 is a whole and a intro and no and a common log. In the ever say my log 1000, nay, I'm fat base be answer and say it's a 10 it will be as a and I will teach you no and add your boy or type of you one fancy hole. In the way answer we be saying about 3. About your and just say, oh, way introduction to logarithm. Introduction, take any you know. Okay, into say a common log, maybe you there. I must see amount log 1 out of 100 to the base 10. 10 no man try. I was who say, hey, why 10? Into we know, if I can say, I'm 5 here and so why, if I told him say the base is 10. And common log, the base is 10. It is there 10 to what power should give us 1 out of 100. And then say 1 out of 100 is the same as 1 out of 10 to the power 2, which is also the same as 10 to the power negative 2. This is the total one x will be equal to saying, hey, this is the bases are the same 10 10, so the exponent should also be the same negative 2. And I want to say what I say if you have a more question okay into question baby you know and most of the time there's a whole year log log a will calculator and so yeah time there not log no common log no calculator and so and a natural log and so also but name 3 put me ball log to any base a calculator and so my calculator and yeah mama yeah time need so into your time no see amount question be say find the log it be 33 base no yeah 5 answer ho and the man say amount log 33 and they say away me time my brother me was school no me use 4-figure tables and maybe that's what o calculator here okay I'm so between the 4-figure tables akọ there was who said they will be see you know only you saw unto me yet Inti, Emma say I'm log 33. You say log 10. We may show week it's where you say log. You say 10 to the power 1, 10. And at 10 to the power 2, 100. Where 33 who says 100 30 and 10 and 10 but 10 is less than 33 and 33 is less than 100 and in this area can log 10 should also be less than log 33 and log 33 should be less than log 100. The idea was also saying so we are log so you can't any in log 1 log 10 base 10 way a1 and log 100 a2 and this is any log 33 a between 1 and 2. You need calculator you but calculator boy but so 4-figure tables are it been in my laptop way so then me 4-figure tables I would be play our animal. But so we use a calculator with me and log 33 to be approximately around 1.518 maybe a 185 yeah and fancy animal. You use 4-figure tables saying it yeah. This is an approximated value of log 33. A name with 3 bet or calculate and bit me abo and once abo log or calculate and once a log be a also abo log now the akoko in him. In the name I say estimate log 530 when I say everyone says you calculate and all year exams and objectives the amount log 530. I never acquire an head no. The answers never out to say answer the day we are. I thought to say 530 between I'm trying to say 100 less than 530 and 530 is less than 1000. I didn't say log log 100 and a less than log 530 which is also less than log 1000. And you say we log 182 and we log 530 and only name the answer no. And then also here less than log 1003. In the answer now no should be between 2 and 3. I will say between 2 and 3. In this who use 4-figure tables and answer would the answer no no say be 2 point number b. It is a objective sir. Nyamin child the answers normally be by be anywhere be 2 point number b. We kwa back open be 2 point it be 7 2 4 maybe 3. Answer kind of be that close enough. Like our fair not to be your answer. So say so what's a log now say they are me de will be see no say. Name no maybe more questions I'm more solving. I'll be giving you more questions for you to try. But before we go, let's assume you are given log 16 to the base 4. Answer base. Log 16 to the base 4. Faculty says answer no should always be an exponent. That's and a 4-way base into the base and then the exponent which we are going to use an x should be equal to then 16 into x we're saying 2. Okay log no add and yet there are several questions we are why Where questions be brave? Some of the union. Some of the questions very thousand. Questions now the baby on the mobile base no member base na yera. To say be a meeting a question be to say. The same idea now the way. And once maybe log 36 to the base x. X now is a down effect to the base x is equal to 2. In the fact of things x way a base. The only man who apply a question be anywhere by the amount. To me the way we went as a way the one share me. X near base and a 2 near the index and our exponent and our power and our way argument. That is just near argument. And here them say the base, which is x, with the index should give you the argument. See, besides a number being our square now will be 36. And see, your numbers mean relative mass in the awareness are. If the final say x is equal to plus or minus the square root of 36, into x can be positive 6 or negative 6. Now, with the entry more, almost a hand way see a pair number is square now. Oh, sorry, number is square now. Ibinya a 36. What square negative 6 are Ibinya 36. And now square positive 6 and so we have 36. Negative 6 squared a negative 6 times negative 6 negative 4 into we have positive 36. And now the x a is 6 and this one 6 times 6 and so 36. Into x is either 6 or 36 or negative 6. Sorry, x is either 6 or negative 6. But yeah, when say the base, okay, I also say the base should always be greater than 0. If the base is greater than 0 there, we are going to consider x to be 6 but not negative 6. So this will be the right answer, not this one. You better reject it and no. Me always say actually I had another video on the laws of logarithm among others. Yeah, you was school mono there no more prove the laws. And say me say no more so more year frame into nya dey between at exams. So we will not be looking at how to prove them. But so here video we now how to prove them and I still remember them. You between approve now. And see me do we say no more. Bye bye.